All right, so the radioactive decay lesson continued. So some transmutations are not straight alpha decay, beta decay, or gamma decay. So some of them don't follow the pattern that we were just practicing. So here's a few like that, just to show you how to deal with it. So example 5, when a boron 10 nucleus captures a neutron, a new element and an alpha particle are produced. Write the nuclear equation for this interaction. So boron 10, we'll write down the numbers for that. And it captures a neutron, which means it is going to take in a neutron. So we're going to add to that neutron. Now the symbol for a neutron, which you should have memorized, is a 1 on top and a 0 on the bottom. And this is going to produce a new element and an alpha particle. So we know the symbol for alpha particle, and then now we have to figure out the symbol for this new element. So we're going to do that the same way as before. So 10 plus 1 is equal to 4 plus x. So that means 11 is equal to 4 plus x. So x is going to be 7. And then on the bottom, 5 plus 0 is equal to 2 plus y. So that means y is going to have to be equal to 3. So we can finish the question now. Top number 7, bottom number 3. Looking on the periodic table, it's lithium. It has an atomic number of 3. So there is the answer to example 5. Example 6. An alpha particle strikes an aluminum-27 nucleus. As a result, a new nucleus and a neutron are produced. Identify the nucleus produced. So same thing, we're going to write down the equation. So we have an alpha particle, and this alpha particle hits an aluminum-27 nucleus. So we're basically adding the aluminum to the alpha particle. And a new nucleus and a neutron are produced. So the symbol for a neutron, we saw what that was on the previous slide. And this makes our new nucleus, which now we're going to figure out what it is. So 4 plus 27 equals 1 plus x. So 4 and 27, that makes 31. 1 plus x, so I can see from that x is 30. And then on the bottom, 2 and 13 is the same thing as 0 plus whatever y is. So y is going to have to be 15. So 30 up top, 15 on the bottom. Element number 15 is phosphorus. All right, example 7. Use the decay series to write the decay equation for radium-288. So a decay series is this chart that you see right here, and it just tells you how something decays. So for example, if we find radium-228 on there, so radium has the symbol Ra, so there it is. This tells us, if we follow radium along to the next dot, and see how here it's telling us, so either move down and to the left or move down and to the right. If we move down and to the right to the next dot, we see that we end up at actinium-228. And we can also see here, because that's a short arrow, right? So notice here, the alpha decay arrow is longer and the beta decay arrow is shorter. Because it's a short arrow, we know that it's going to be a beta decay. And so let's write it out. So radium-228 is what we're starting with. And from the periodic table, this has an atomic number of 88. This is going to decay into actinium-228. And I'm just getting that from right here. It tells me there that that's actinium-228. And now I'm looking on the periodic table to see if I can find actinium. So it's at the very bottom of the periodic table. It's element number 89. And now what I need to do is I need to look at how this equation is going to be completed. So first of all, I have to see if it's going to be a beta positive decay or a beta negative decay. So because 88 turned into 89, that must mean that it's a beta negative decay. Because if I add on here a beta negative particle, right, -1 and 89 together are going to add up to 88. And so that's how I knew it was beta negative. Now, this isn't the complete equation because we know when we have a beta negative particle, one more thing is released, and that's going to be an antineutrino. So the symbol for an antineutrino